Hi, in this video, I'm going to show you examples how to calculate percentiles. A percentile tells us what percent of observations are less than or equal to a given value in a distribution. So let's go ahead and look at a few examples how we would calculate that. So you can be asked to calculate a percentile given an observation, or you can be asked to find an observation given a percentile. So let's look at an example. So here we have a dot plot that represents dry ice for ice cream for shipping. The dot plot shows the density in kilograms per cubic decimeter of 15 blocks of the dry ice. All right, so what's important here is that our sample size is 15. Okay, so our n equals 15. That's the first thing to observe. And if you notice, we have 15 dots on the dot plot, and it asks you which of the following is the closest estimate to the percentile for a block of dry ice with a density of 1.5 kilograms per dm cubed. All right, well, where is 1.5? It is right here. And if you remember that, what is a percentile? It is the percent of observations that are less than or equal to a given value in a distribution. So if I look at this is the observation I'm interested in, and the percentile is where this is at compared to all the observations. So because I have 15 and this is the 13th item, basically the percentile is just calculating 13 out of 15. You would enter that into your calculator, and that would give us approximately probably 80 something percent. So 13 is 86.666. So we can say this is approximately the 87th percentile. So the 87th percentile is where this observation is at. All right, let's take a look now at a problem where you are given the percentile and you want to know the interval which contains the 60th percentile. So let's again look at what is our sample size. It says the histogram summarizes the number of tropical storms per year in the US for 30 years. So I have 30 years here, so that is our N. And you could see from the histogram, if we counted, it is the number of years right here. So it is counts, number of years. So I have 1 over here. I have 7 here. I have 5 and 4. And if you counted all this up, you would get a total of 30. So they're asking you in which bin would be the 60th percentile. Well, really, all you need to do is find what is 60% of 30. So you basically multiply 30 times 0.6, okay? 60 percentile is 0.6. So if you do 30 times 0.6, you will get 18. So be careful. What you want to do here is you're not going to go to the 18 where between 0 and 25. You're going to go to the 18th observation. So where would the 18th observation be? The 18th observation is, well, I already put the counts on the top of the bins. So the 18th observation, let me change the color of the pen. The 18th observation would be, this is 1, this is 8. So 1 and 7 and 8, and 5 is 13. 13 and 4 is 17. So the 18th observation is between 100 and 125. So what is the interval containing the 60th percentile? It is this interval right here. That is between 100 and 125. All right, let's go ahead and see another type of problem. This time with a stem and leaf. How would we do something within stem and leaf? All right, it says, what would be the percentile of the students who travel 4 kilometers to school? So again, what's important is to look at our sample size. We have n equals 30 is the number of students we are looking at. And we want to know what percentile is for the students who travel 4 kilometers. Well, look at the key right here. 7/9 means 7.9 kilometers. So 4.0 would be right here. So remember, I want to use the observation. The percentile is all observations at or less than 4. So because we have 30 items, instead of counting how many we have below, I could see it would be easier to see that I have 1, 2, 3, 4 above. So basically this observation right here is in the 26th out of 30. So that is actually my percentile that I can calculate. So if you enter into your calculator 26 out of 30, that will give you the percentile of the students who travel 4 kilometers. So 26 divided by 30, that is, again, about 87th percentile. So this would be the 87th percentile. So the 87th percentile. All right, let's go ahead and look at this problem. If you want to pause this and try this on your own, then go ahead and do so and see if you can get this correct. It says the following dot plot shows the number of songs on each of the 19 albums in Sal's collection. Each dot represents a different album. Okay, so we have 19 albums total, and we want to know which is the percentile of the album which contains 14 songs. Well, here are 14 songs right here. So where is this at? Remember, the percentile is the everything below this number, 14. So added or below it, okay? So including this or not including it would be the percentile. So either one you can calculate. So this item right here out of 19, so we have 1, 2, 3, 4. So this would be the 15th album out of 19. Okay, you can count it just to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so we can enter 16. This is the 16th album right here. So basically you're going to calculate the percentile of 16 out of 19, and that would give us 84.2%. So this is about the 84.2 percentile. So in other words, 84% of the observations, in other words, in this case, albums, are below here. Okay, let's go ahead and look at another problem. All right, so how would you calculate this with a box plot? Because you could really be given any type of graph. So one thing I want you to remember, which is always going to be true for a box plot, is in the 25th percentile is our Q1. Remember, a box plot is divided into 4 quartiles. So your Q1 will always be the 25th percentile. Your median is actually always your 50th percentile. It always is going to divide your data in half. So this is the 50th percentile. Then we have the 75th percentile is always going to be our Q3. So if I wanted something that was in the 85th percentile, I know that 85 percentile is somewhere above 75. So it'd be somewhere around here. If I wanted to know something in the 30th percentile, it would be between the 25th and the median. So in this quadrant right here. If I wanted something in the 20th percentile, it would be in this quadrant here. So let's go ahead and see what we have next. All right, so here we're going to look at an example with a cumulative frequency graph. And so if you can see a cumulative frequency on the y-axis adds up to 1 always. So this represents percentages. So if I converted these numbers, this is actually here 20%, 40%, 60%, 80%, and 100%. So the question asks, what is the 25th percentile of sugar content? So this graph represents sugar content, and here's the cumulative frequency, the relative frequency as the y-axis. So if I wanted to know the 25th percentile, well, the 25th percentile is just look at the y-axis, go to 25. So this is 40%, 20%. This right here is 0.3. So the 25th percentile would be somewhere halfway between 0.2 and 0.3. So I can actually extend this along to the plot and see where it is approximately. And then I will go down with a vertical line to see where it's at. So we could say it's approximately 18 grams. So this is an approximate, okay, because it is not exactly landing on the corner of a square. It's in between. So we would say approximately. So we can say squiggly lines like this, wavy lines saying approximately 18. All right, what would be the 75th percentile? Well, I can do the same thing. 75th percentile, looking on the graph here, this would be 0.7. So I'm going to write 0.7 here. And 0.75 would be 75th percentile. So I'll go in between 0.7 and 0.8, extend that halfway. Let's see where that takes us approximately. It looks like it goes, and then we can go down. So if we went down, it looks like it would be maybe 38 grams. So we can say approximately 38 grams. So one other thing is, guys, the 25th percentile happens to be your Q1. And your 75th percentile is also your Q3. So you don't have to have a box plot or a picture of a box plot to say what is Q1 and Q3, because Q1 will always be at the 25th percentile and Q3 will always be at the 75th percentile. Now, if you recall, the median is always at the 50th percentile. So the 50th percentile is right here. So I can extend the line to 50% and see, and it looks like this one is easier to tell. It's right in the middle. It's 25 grams. So the median of sugar content is 25 grams. And by the way, we also sometimes call the median Q2, although we rarely use that, Q2, but Q2 is in the middle. And now the question asked, this is a common question, is what is the IQR of the sugar content? If I want to know the IQR, all we need to do is subtract Q3 minus Q1, and we already have calculated Q3. So we already know Q3. Basically, I'm going to subtract that. Q3 is 38, and Q1 is 18. So the IQR of sugar content, we would say, is 20 grams. Now, make sure you always use the context. So in this case, you should use your units, and you should answer the question in a full sentence. The IQR of sugar content is 20 grams. The median of sugar content is 25 grams. The 75th percentile of sugar content is 38 grams. And the 25th percentile of sugar content is 18 grams. All right. So go ahead and try this one. Pause the video and see if you can find what is the percentile of 40 grams of sugar. So use this graph to find what the percentile is. And I will go over it right now. Well, you could see on the graph that 40 grams is right here. So if I want to know what percentile 40 grams is, I could just draw a line up to see where that is. And it is right here. If you go across, you notice that that is 0.8. And remember, this is a cumulative relative frequency. 0.8 represents 80%. So this is the 80th percentile. So 80th percentile. Percentile.